Okay, so the first thing we're going to talk about are terminal points on the unit circle. In this textbook, they are going to be calling values t. So we're letting t be a real number, okay, and that's going to represent the distance traveled on the unit circle. Okay, the distance that's traveled is going to be measured in radians. So it's going to be an angle measure. And then the point that you get is called your terminal point. Okay, so for your first one, they tell you that your value of t is pi over 2. Okay, so if you travel to pi over 2 on the unit circle, you are right here at the top. And then your terminal point would be 0, 1. Okay, each one of these is going to give you an example of the t and then the terminal point. So if your t value is pi, that means you end up here on the unit circle. So your terminal point would be -1, 0. Okay, terminal is where you end up. Where's the point where you end up? Okay, and then your t is measured in radians. If it's 3 pi over 2, that is going to put us at this point. Oh, did I just start at the point? I need to do that in a different color. Okay, so you always, whenever you're measuring this, you always start at 0. Okay, and then this is your point. So your point is going to be 0, -1. All right, and then the last one we have is 2 pi. So we would start at 0, travel all the way around the circle, which would put us at 1, 0. Okay, and we're going to have different values. So those are just 4 of your standard values here. Okay, and then in example 3, you have to find the terminal point on the unit circle when you are given a value of t. Okay, so you should notice some similarities to concepts that you've studied before. So if t is 5 pi over 3, okay, you're going to have to be able to do this without looking at a unit circle. One thing I recommend is writing out quadrant 1. Okay, so quadrant 1 is the only quadrant that you have to have memorized. And then from there, you can transform your different values. Okay, so a lot of times I do a visual representation. Some of us are visual learners, and that helps with understanding how the radians work. Some of you might not need that as you're doing your assignment today. That's okay. But this is how we make our thinking visible. So I want you to have this on your notes, okay? So if you're at 5 pi over 3, some of you are going to know right away that that's in quadrant 4, because isn't 2 pi 6 pi over 3? So you would just go 1 pi back. Okay, some of you are really good at that. Others of you might need to do a counting approach, which is where you can think of this as 5 times pi over 3. It just depends on how familiar you are with radians from your previous classes. So we should know pi over 3 is 60 degrees. So if I go 60 degrees 5 times, this would be 1 pi over 3, 2 pi over 3, 3 pi over 3, is that pi, so that's good, 4 pi over 3, and then 5 pi over 3. The main thing you want to do is see what quadrant you're in so that you can adjust the point for that quadrant. So we know in quadrant 4, based on what we did yesterday, you have a positive x and a negative y, and then you just have to use your reference angle here. So the first quadrant is one you should have memorized. Your pi over 3 is 1/2 √3 over 2. Okay, again, you can write out your first quadrant so you have that for reference. So now we know that our point is going to be the positive x and then the negative value of the y. Okay, if you are using that strategy, what you are doing is you are using the reference angle of pi over 3, and we are adjusting the signs for the quadrant. Okay, the more practice you do with this, the easier it will become. I know for some of you, if you remember a lot of the stuff from last year, if you can recall that easily. Okay, I know this will go quickly for you. All right, so I want you to do t equals negative 3 pi over 4. So recall if it's negative, okay, you're going to go in the opposite direction. So with the unit circle, normally we go counterclockwise if it's positive. So we're going to go the other direction if it's negative. All right, so what quadrant did negative 3 pi over 4 end up in? 3. Okay, so again, we can separate it like this. It's negative 3 times pi over 4. Pi over 4 is how many degrees? 45. Okay, so I'm just going to go in the negative direction. This would be 1 pi over 4, 2 pi over 4, negative 3 pi over 4. Okay, so that's in quadrant 3 where both the x and the y are negative. And again, you're using your reference angle. Okay, so if you know at pi over 4, it's root 2 over 2, root 2 over 2. All you have to do is make that adjustment. Okay, and you won't need to show like all of this work on your assignment. This is just to help you understand what we're using in order to make the adjustments. So we have this pi over 4. Okay, remember it's the same point. That's the activity we did yesterday. Remember how you have those same points in every quadrant? The signs are just adjusted. We did those on the circles on the front. It's so that we can do stuff like this quickly, okay? All right, then we're going to talk about the reference number. Okay, and the reference number says let t be a real number. Okay, and then the reference number has a special notation here. It's your t with your line above it. Okay, that's associated with t. That is the shortest distance along the unit circle. So the shortest distance along the unit circle between the terminal point and the x-axis. Okay, so we did find reference angles last year. Here they call them reference numbers. Last year we also worked with degrees a lot more. We're kind of skipping right to these radian values. That's the main thing that we're going to be using. Do you guys remember a couple of the properties of reference numbers that we talked about last year? Yep, they have to be between 0 and pi over 2 and positive. Okay, so this value is always a positive value in radians. Okay, between 0 and pi over 2. Okay, it can equal pi over 2. The only time it would be 0 is if you had 0. So if you have a point in quadrant 1 or in quadrant 4, you have a few special properties. We're going to use a different point than what they do there because I like to start with quadrant 1 and 4 instead of 2 and 3. Okay, so we're just going to make, I just want you to make a point in quadrant 1. If you have a point in quadrant 1, the shortest distance, you have two options, right? It's either going to be to the positive x-axis or to the negative. Which is the shorter distance? To the positive. Okay, in quadrant 4, it's going to be the same thing. It doesn't matter where you put the point there. Okay, the shorter distance is going to be to the positive x-axis. Okay, so your value goes to the positive x-axis. Okay, and then for 2 and 3, again, we're just going to put a point. You can put it anywhere in 2 so that you can visually see this is the shorter distance. Your options are either the positive x-axis or the negative x-axis. So in this case, the shorter distance will always be to the negative x-axis. And that's so you will never cross one of the axis lines. Okay, if you cross that, that means it would be greater than pi over 2, greater than 90 degrees. Okay, and we know that that will not be in our range of our values. Okay, so we're going to find the reference number for each value of t. Okay, when you did this in Algebra 2, it was called finding the reference angle. So I'm going to have you do A and B. So in A, your t value is 4 pi over 3. In B, it's negative 4 pi over 3. Okay, what I'd like you to do is I would like you to make a visual representation of where those values are. So what quadrant does it end up in? Okay, and then feel free to use little tricks as you're doing your unit circle. Like if you're at 4 pi over 3, right? Don't you know where 3 pi over 3 is? Isn't that the same thing as pi at 3 pi over 3? So then if you want, this would just be your 4 pi over 3, okay, in quadrant 3. So when you are finding the reference number, you are just finding this distance. From 3 pi over 3 to 4 pi over 3, what's that distance? Pi over 3. 4 pi over 3 minus 3 pi over 3 is pi over 3. Okay, and then you can use a similar logic for this. This would be negative 3 pi over 3. So this would be negative 4 pi over 3. It's in quadrant 2. So in quadrant 2, okay, we go to the negative x-axis. What's the distance between negative 3 pi over 3 and negative 4 pi over 3? Pi over 3. So again, it's always positive. So it's not negative pi over 3. The distance is going to be positive. Okay, you went back to negative pi over 3. That would be the angle measure. The distance is going to be positive. Okay. Oh, and then I was just going to write that this is what this is your symbol. Okay, so this is stuff that you guys have done before. The next part might be a little bit new. So we've worked a lot with these special places on the unit circle. What if it's not a special place on the unit circle? Let's learn how to navigate that. So we have something, we have t equals 5 pi over 7. Okay, so again, we're going to start with that visual representation. Okay, I'm going to give you a moment to see if you can just figure out what quadrant it's in. So I want you to think about how you can figure that out. There are a few different ways you can do this. I want to give you that time to think about it. And I'm going to ask some of you to share in just a moment. All right, what do we think then? Okay, Griffin?
Yeah.
I didn't hear what she said. What? No. But what quadrant was it in?
Quadrant.
Okay, so quadrant 2 is correct. And can you explain how you deciphered that? How you determined it?
I thought of 7 pi over 7 being like just 1 pi.
Yeah.
So that would be at that spot, and then half 4 pi over 2 would be like 3.5 pi over 7.
Yep.
And then so I knew it would be quadrant 2 bigger than 3.5.
Exactly. So if you know that 5 pi over 7 is larger than half, but also less than 1, you know it's going to end up somewhere in quadrant 2, okay? And I'm not going to be like really picky on the accuracy of that because we don't need it for this. So if you say that this is your 5 pi over 7, okay, you are finding this distance. Okay, so to find that distance, you would have taken 7 pi over 7 and subtracted 5 pi over 7, okay, which would give you 2 pi over 7. Okay, another way that you could do it is you could think of it as 5 times pi over 7, and don't we know how to convert that based on what we did yesterday? You could approximate what it is. Okay, you could do, because remember, you can do pi over 7 times 180 over pi. Okay, and you can estimate if you do 180 divided by 7, it goes in there twice. You're going to have a remainder. So 25 and 5/7. Okay, if you want to round to 26 or even 25, because I think that's a little easier, okay, you could count 5 times of 25 and estimate where that would be, right? You could just do, you round it to 26 and do times 5, that would be 30. So it would be approximately 130 degrees, a little bit less, and that would tell you within quadrant 2. Okay? All right, and then again, you would have to do the 7 pi over 7 minus the 5 pi over 7 once you realize it's in quadrant 2. All right, I alluded to this the other day that not only are we going to be working with some different radian values do not have to have pi in them. So sometimes you might just have 5.29. Okay, when they give this to you, it's always going to be in radians. Okay, so even if it doesn't say radians, it is going to be your radian value if you don't see the degree symbol. Do you guys want a minute to try to figure this out by yourself? figure out what quadrant it's in, and then we'll chat, okay? Okay, if you're unsure where to start, think about pi, right? Nope, it doesn't have the pi in it. Okay, so we know that it starts at 0. What do you guys think pi is as a number? 3.14, right? So if pi is 3.14, right? That's how many radians it is. That's what it is as a decimal. How can we figure out what these other places are?
Multiplied by 2 equals 5.
Yeah, so this,
That would be 6.28.
okay, and then how can I figure out what this is?
That would be divided by
Yep, so if we cut 3.14 in half, what's half of 3? 1.5, half of 4, what's half of 0.14?
0.07.
Yes. Okay, so are you guys with me on the fact now that we know pi over 2 is 1.57? Okay, so pi over 2 radians is the same thing as 1.57. So if you do 1.57 plus 1.57, you're at 3.14. So to get to this guy, you're at, what would the next part be? What is this? What is this guy? Okay, so please write those down because in this one we have 5.29, but you're going to have other ones that you're going to need to know. So if you just convert those into decimals, okay, you can leave them just like that because we're still going to do it without a calculator. We don't need it. Pi is 3.14 times 2 divided by 2. Okay. So now we know that 5.29 is in what quadrant? Quadrant 4. And again, I don't care where you put it, as long as it's in quadrant 4. Okay, so we know it's in Q4, which means your reference angle goes from, okay, here to here. That's what you're trying to find. What we just graphed is this, here to here. Okay, so how can you find this highlighted region in pink? Subtract from 6.28 minus 5.29. Okay, so if it doesn't have enough, you borrow. So 18 minus 9 is 9. Okay, not enough, so you borrow. 11 minus 2 is 9. Okay, so your t value is 0.99. Okay, so this is going to be very helpful when you have your decimals. Our last example is just examples 3 and 4 combined. You're going to find the reference number and the terminal point for each one. Okay, so your t is negative 7 pi over 6. And for B, your t is 13 pi over 4. All right, I'm going to give you a minute to try the first one. So again, you're going to put that in your quadrant. Okay, so if it's negative, remember when you are deciding where this goes, you're moving clockwise and I gave you some hints earlier, right? If you know this is pi, isn't this just negative 6 pi over 6? So negative 7 pi over 6 is in quadrant 2, okay? So when you are finding your reference number, it is the distance from here to here. Okay, that distance is what? Pi over 6. Okay, now we're going to do the point. So your point is based on what pi over 6 is, okay, as your reference angle. Cedric, would you mention that one? Thank you. Okay, so at pi over 6, you are at root 3 over 2, 1/2. Okay, and so we're going to adjust it for quadrant 2, which is a negative x and a positive y. Okay, so negative root 3 over 2, and then 1/2. Okay, and then think about where your 13 pi over 4 is. Okay, so what would one full time around the circle be in terms of pi over 4? 8 pi over 4. Okay, so 2 pi is equivalent to 8 pi over 4. And we know that pi over 4 is how many degrees? 45. Okay, so if I'm at 8 pi over 4, then I go 9, 10, 11, 12, 13. Okay, so 13 pi over 4 in quadrant 3, you have both negative values. Okay, we know at pi over 4, we have root 2 over 2, root 2 over 2, so we're just going to make those adjustments. Okay, the first value is this distance. Okay, so if you were at 12 pi over 4 here, and you subtracted, you would get pi over 4. Okay, so your value for t, which you should be noticing a pattern emerge with these special places on the unit circle. Okay, and then we're just going to adjust it. So in quadrant 3, they're both negative, so both of your points are going to be negative. Okay.